hang up and try again.
In this session, we're going to talk about how to compare strings in Java. And we recognize that in the past, we used the 6 relational operators to compare two different types, in most ideally primitive types. So everything that is an int, a long, a short, a double, a float, a byte, a char, and a boolean. But I don't know if you remember, but in the past I have mentioned that strings are not primitive types. Strings are objects. And since Java is an object orientation programming, it's kind of fair to mention that Java will use or will treat the string as an object. And a couple of other items that we have to recognize is that strings, they have also methods. And the methods, they help us to make operations internally, like the length, like the char at, like compareTo, to uppercase, to lowercase, substring. There's a lot of different things that we can do. So most of those things you can find in the Java API. But today I'm going to talk about how compare strings. It's kind of important because here we're going to use another functionality called a method that is named it's compareTo. So every time you deal with objects, you have to use compareTo. In this case, string will represent the object. So let me just create the skeleton real quick of the class that we're going to use. The very first thing, we're gonna ask the user to enter 2 strings, and we need to make sure which one is smaller, which one is greater. And that's pretty much the question that many of my students, they have: how to compare strings in terms of what. So I'm gonna call my input, again, is the scanner that we're gonna use from the console or with the terminal, and we're gonna expect here name1, right? So I'm gonna call it name1, and it's going to come from input.next line, so like this. So I guess it's fair to ask the user to enter the first name, right? Enter. And similar, I'm gonna do the same thing. I'm gonna compare 2 strings. So I'm gonna use the second, and I'm gonna compare 2 things here. Now, I want you to pay attention here. On line 6, I have a string that is obtained from the computer user, and in line 8, I have another string obtaining from the computer user. So the way we compare, ladies and gentlemen, there's another video that I will explain by detail, like the very lowest level. In case you don't understand this part, you're welcome to go and watch that one. The way we're gonna have to print is in increasing order or ascending order. Remember that increasing order is from lowest to highest, but lowest to highest makes sense when we deal with numbers. When we deal with strings or characters, how can we consider that increasing order? You might think that you can put it in alphabetical order, and you're right, okay? Alphabetical order is a good way to measure this ordering. But in reality, there's no such a thing as an alphabetically order. Alphabetically order is for humans, right? So of course we're humans trying to understand machines, but in reality, they're machines trying to understand from humans. So here what we want to do is that we want to give the lexicographically order. I know this is a big word, this lexicographically order, but that is really what I really mean. Lexicographically order is the order that the computer, the machine, will recognize the words that we input. And I don't know if you remember that table that I mentioned in a couple of weeks ago about the ASCII codes and the hexadecimal values. That is considered to be the lexicographically order. There is an ordering of, for example, special characters, and then numeric values, and then lowercase values, and then uppercase values. In other words, a lowercase and an uppercase letter A, they have different Unicode value. A number 5 versus a character Z has a different numeric value. So that is considered to be lexicographically order, because this is the ordering of the lexica. That's why we need to consider that part. Now, the way the real Java performs is to check character by character by using char at, as you probably remember from other lessons. But here we want to have which of these 2 names goes first. So we're gonna use the actual if statement to compare here. If name one, and I want to see this, if name one, and I want to understand that I want to do this for the ordering only, is less than name two, we want to print in ordering name one and then comma name two. Now, if it's not true, then what we want to do is basically the opposite. Now, this seems to be legit for to print basically the values in ascending order. So in other words, if name one is, for example, Alice, and name two is Bob, you're gonna check, is Alice smaller than Bob? If it's true, then we're gonna print Alice and then Bob. But if it's not true, if name one is Bob and name two is Alice, we want to go to the next part in order to print Alice and then Bob in alphabetically order, in other words, alexicographically order. This less than, notice that Java is complaining. I'm not so sure if you can see the complaining part, but it says, hey, the operator less than is undefined for this type. You cannot use the less than using strings. Why? Because a string is not a primitive type. Less than, greater than, equal, not equal, greater than or equal, less than or equal, they're only used for relational operators that work with primitive types. So that's why name one and name two in their string, they're not primitive types. So we cannot use this logical thing. So there is a thing called compareTo. Now, we still want to have this ordering, and the way we're gonna use is to use the .compareTo, and then we enter name two, and we close it. Now, we can use less than 0. Check this out. Now, Java is not complaining at all, okay? So Java is now saying like, okay, we're fine. So what the heck just happened here? So the less than, we still have to understand that we're gonna use it. The only thing that we're changing here is that we're not using it between name one and name two. We're using that compareTo open parentheses and the name two close parentheses. That's the way we compare it. And then the 0, why is the 0, professor? So compareTo, ladies and gentlemen, will give you a number. Actually, as a matter of fact, we'll give you two things. It will give you a number and a sign. The sign will be positive or will give you negative. The number positive will tell you that the right-hand side value is larger than the left-hand side, that is the compareTo. If it's negative, that means that is the opposite, that the value in the name two, it should be smaller than the value in the left-hand side. If it's 0, ladies and gentlemen, that means they are the same. So that's why 0 is a very important number. It will tell us if it's different from itself. Check this out. Let's run this. Let's save, compile, and run this program. Enter the first name. So I'm gonna put here Bob and then Alice, and I get Alice, Bob. Now the second time I'm gonna use Alice and I'm gonna use Bob, and then I get Alice and Bob. Now notice that if I put here Alice, Alice, what do you think is going to happen? So after running this, we're gonna enter on line 6 Alice, and then on line 8 we'll print also we'll get Alice. So Alice compared to Alice is the same. So that is not less than 0. So it will just come here directly and we'll print the name Alice, comma, Alice. Okay, that's fair enough. So we want to kind of make sure we have a statement that identifies duplication. How about that? So the way we're gonna do this is we can create another statement saying like this. As a matter of fact, I'm gonna kind of copy and paste this thing and then do this following thing. We're gonna compare. If they're double equal to 0, that means they're the same. And then we can say a program like duplication, duplicate found. Now, if it's not the case, we should put an else if. Then we compare if it's smaller. If it's smaller, we're gonna print this way. If it's greater, we're gonna print this way. Does that look like a plan? Let's save, compile, and run. We found the duplicate. If we run it again, Alice and Bob, it will print Alice and Bob, and it will print here Bob and then Alice. It will put us in alphabetically order. Now check this out. I'm gonna put here Alice, and I'm gonna put here lowercase Alice. What do you think is going to happen? Uppercase Alice will go first, followed by lowercase Alice. And that is because there is a lexicographically order. And that table that you probably remember, you already know that uppercase, they have a highest value from the lowest value. So that is a very important notice. Now, suppose that we're gonna have some kind of weird names, right? Starting with, for example, 5672. And then the second name will be Alice. What do you think is going to print? Interesting, right? Check this out. So the number goes first, and then uppercase Alice goes second, because that is part of the lexicographic. I already mentioned, but in the table, we already know that thing. Now, the last experiment that I'm going to do here is going to be Alice and Alice I. Why? What's going to print first? It will print Alice and then Alice Y, because E is first in the alphabet or in that table that use the lexicographically order. So that is very interesting. You need to pay attention on those items always, because the idea here is to, if A, uppercase A is the same as the uppercase A, Java will go to the next character, which is L and L. And if it's the same, it will move to the next one, which is I and I. And if it's the same, it will go to C and C. And if it's the same, it will go to the next one, which is E versus Y. And E has a higher degree in this case. That's why Alice with an E, it will go first, and then Alice Y will go second. Interesting, no? So that is what we call the lexicographically order. I decided to spend a little bit more time on this example because different mechanisms that you're using that requires this kind of understanding with the lexicographically order. In other words, the compare to. It's important to recognize these aspects in programming, how to compare strings.